In a low vision exam, the first hurdle is often the eye chart itself. When a patient has significantly reduced vision, they might not be able to read even the largest letters at the standard 6-meter testing distance. The immediate clinical solution is to bring the chart closer to the patient. By doing this, we increase the angular subtents of the letters, making them physically larger on the retina. But once we change the testing distance, we have to calculate what their vision would theoretically be back at 6 meters. This LogMAR scale shows exactly how we make those calculations. Unlike a standard Snellen chart, LogMAR is built on a strict geometric progression. Every step up or down this ladder represents an exact equal change in visual demand. Let's set up a baseline scenario. Suppose your patient can only resolve the 60 line when the chart is moved up to 2.4 meters. To find their 6-meter equivalent, we use the ladder to count the geometric steps. We start at 2.4 meters and count back to the standard 6-meter mark. That is 3, 3.8, 4.8, and 6. Exactly 4 steps further away. Because the patient needed to be 4 steps closer to see the target, their actual vision is 4 steps worse than the 60 line. We apply those same 4 steps to the acuity column, from 60 to 75, 95, 120, and finally 150. Their recorded distance acuity is 6/150. The LogMAR geometric progression allows us to take non-standard clinical measurements and convert them directly into objective, standardized data, regardless of the size of your exam room. Now let's examine near vision testing, which we measure in N notation. In low vision patients, you will frequently see a mismatch between their distance and near performance. To bridge these two notations, we use a baseline equivalence. An acuity of 6/60 at distance is theoretically equivalent to reading N20 text at 25 centimeters. We use this relationship to solve comparative problems. If a patient reads N48 at that standard 25 centimeter distance, what is their Snellen distance equivalent? Starting from our baseline of N20, we track the steps up the scale to N48. That takes us through N24, 32, 40, and 48, a 4-step decrease in visual performance. We match that movement on the distance side. Dropping 4 steps from our 60 baseline takes us through 75, 95, and 120, landing straight on 150. The geometric progression remains perfectly consistent across both testing modes. Let's increase the complexity with a non-standard near distance. A patient reads N12, but they have to hold the text at 16 centimeters. What is their 6-meter equivalent? We handle the distance component first. To get from their holding distance of 16 centimeters back to our baseline of 25 centimeters, we move 2 geometric steps, from 16 to 20 to 25. Because they had to hold the text 2 steps closer, their actual acuity is 2 steps worse than N12. Moving 2 steps down the N notation ladder brings us to N20. And since we know N20 at 25 centimeters is our baseline, their distance equivalent is exactly 6/60. This conversion highlights whether a patient's near vision aligns with their distance performance. If it doesn't, it signals that secondary factors, like a central scotoma, are disproportionately impairing their reading. Let's bring this all together to solve a practical clinical goal. A patient currently reads N16 at 40 centimeters, but they need to read N6 newsprint. We have to find their new required viewing distance and the exact lens addition needed to achieve it. First, we map the visual demand. To get from N16 down to N6, we count the steps on our ladder: 12, 10, 8, and 6. That is a 4-step improvement required. To achieve that 4-step gain, we must bring the text 4 geometric steps closer to the eye. Starting from 40 centimeters, we move to 32, 25, 20, and finally land on a required viewing distance of 16 centimeters. Now that we have the physical distance, the final step is providing the dioptric power so the eye can accurately focus on a target held exactly 16 centimeters away. We use the standard focal length formula, 1 over the distance in meters. 1 divided by 0.16 meters gives us plus 6.25 diopters. In the clinic, we round this down to prescribe a plus 6 diopter near addition. The LogMAR ladder moves low vision prescribing away from estimation and toward a structured framework. It provides the specific calculations required to optimize a patient's vision for the tasks they value most.